This video will cover section 2.3, intersection and union of sets. Okay, so it's going to go continue off of the previous lesson on what a set is and a couple more notations. Our first definition that we have here is that the intersection of sets A and B, denoted by this symbol here, A intersect B. So we have this like upside down, oh, bad color to choose. Upside down U of sorts, okay? A intersect B is the set of elements common to both A and B, okay? So this is known again as the intersection of sets. You might have seen this in your class at some point. It's equivalent to an and statement, okay? So it's kind of like saying A and B. That might be more familiar. So and would be associated with this upside down U looking figure, okay? So basically what it is in mathematical notation is we have A intersect B is equal to X, which meaning, some kind of number such that all X is in A and X is in B are in both sets. So elements that are in A and elements that are in B would satisfy this condition. So let me go ahead and just jump right into an example so you can see how this definition works, okay? We have that A is equal to 0,389 and B is equal to B is equal to 3,489 and C is equal to 0,268. So we're going to start with A intersect B. That means I need to find all the elements that are in A, so A, and B. So I really don't care about C at this point. I'm not even going to look at it. So all I'm going to do is compare the elements. So let's go ahead and set up our little curly braces here. Let's see, A has a 0, B does not. So 0 is not going to go into the set. A has a 3 and so does B. So 3 is one of the elements that they both have in common. Okay. A has an 8 and so does B. So 8 is also going to go in this set. A has a 9 and B also has a 9. So 9 is going to go in this set. Now notice that B also has a 4, but A does not have a 4. Therefore, 4 is not going to go in this set. So A intersect B is equal to the set 3, 8, 9. Okay, so let's try another one. So for letter B, we have A intersect C now. So now I'm going to be looking at this one here. So let me erase these little things right here. Now we're going to be looking at A and C. So this one and this one. And it's the same idea. So we're going to just compare. So let's see. In this case, they both have a 0. So 0 is going to be my first element. Okay. Let's see. This one has a 3. This one does not. So 3 doesn't go in there. 8. This one does have an 8. And this one also has an 8. So 8 goes in there. Okay. 9, no 9. And no 2 in the A, no 6 in the A. So in this case, this one only has 2 elements. So cardinality would be 2. Cardinal number, remember the number of elements in a set. And that's it. So this is how you do intersections. You compare the elements that are inside and see what they have in common. Whatever they share is what goes in this intersection. Okay? We're going to go ahead and move on to another definition. This one is known as the union of sets. So this one, I'm pretty sure you've seen when it comes to domain and range in Algebra 2 at some point. This one looks like a U, okay, without the little tail, but it's a U and it stands for union. Okay, that's one way to remember it. The union of sets A and B, denoted by A union B, is the set that contains all the elements that belong to A or B or to both. So this is also known as an or statement, okay? So union is the same as or. In other words, we have our elements X such that X is in A or X is in B. In other words, it's everything that, as long as it's in one of them, it's part of the set. Okay, so we're going to go right into an example. It's kind of like the opposite of the one before. okay? Complement in a way. So we have D or E. So if the element is in this one or this one, so D or E, then it's part of the set, okay? So let's see. D has a 0. Um, this one has a 1. I'm going to go ahead and put them in order just because we do put them in ascending order. They both have a 4, so we only write it one time. We don't have to write it twice, okay? Let's see, what will be the next one? 5, and then 7, because this one has a 7 here, and then 8, and then 9. So all these elements are either going to be in here or in here. And that's the definition of a union. As long as it's in one of the sets that we're talking about, then it is part of the answer. It's part of the new set that we're building. Okay? Let's see, what else? Next one, letter D. So for this one, we're going to be comparing D and F. So we're going to look at a different one in this case. Let's see, I'll use green. So I'm going to look at D and F. So I no longer care about E, so we're not going to look at that anymore. And it's the same idea, so whatever's in D or in F. So let's go right into it. So D has the first slowest number, so I'm going to go ahead and put that 0 first. And then it looks like 2 is the next one. And then 4, 6. They both have an 8, but remember that we don't have to write it twice, we just write it once. And then 9. And that is it. Okay. So this one's not too bad. It's actually, I think at least at this level, it's just a matter of comparing the numbers. Okay. See if we have anything else. Oh, we do have some more stuff down here. So now we're going to go ahead and translate what we did here numerically into a description. So let's say we have, for example, letter A, where we have A union B intersects C. So I'm going to go ahead and write what these things mean just because we tend to forget. So this one means union, or it could also be known as an or statement, okay? And then the other one, this one right here, is the intersection. So intersect, also known as and. So in other words, it has to be in both of them, okay? And we're just going to describe this in a sentence. So I'm going to go ahead and start with the set of all elements. Let me see, I'll use yellow. So for letter A, I'm going to say this is the set of all elements. You could start your sentences like that as well. In A, because they are in A, or, okay, in B and C. That's it. So you're just translating what this means into words. Okay, let's look at the other one. I'm going to use a different color for this one. So over here we have J. What is this right here? Let's see if you can remember. And, okay. And then we have an extra little thing here that we might have forgotten. Hopefully we didn't, but that little like apostrophe looking thing, remember that means complements. Or you could also think of it as prime, so K prime, but it means not in K. So anything that's not in K, all right? So just don't forget that. So I'm going to go ahead and write this. So this, again, we're going to start with the sets of all elements in J, because that's the first one, and, where's my and, not in K. Because remember, this right here means this right here. And that's it. That is a verbal description of what these notations symbolize, okay? We're going to try a few more just for the practice. So at this point, I think I would like you to pause it and see if you can figure these out, okay? Otherwise, go ahead and just check your answers. So for this very first one, we have, let's see, let's start off with our sentence. So the set of all elements we start out with D. So within D, what is this again? And, so and. Remember, this is not, this is or. So, and not in E or in F. I do have to put that in F because I don't want you to think that it's not an E and it's not an F. So not an E, but it is an F. Okay. And the last one. Let's use a different green. So this one right here is going to be an or statement. Okay. Remember that this means not, that little thing right here, that little apostrophe thing. So again, the set of all elements not in L or in M. Okay, that's it. That is a pretty nice brief description of what these represent. Okay, and now we're moving on to the ones that are a little bit, where it starts to get a little bit interesting. Okay, so we're going to go ahead and do another example, kind of like the one from before, where you had to see what they had in common or not in common, but we're going to use multiple operations. So we have that U is equal to all of this, A is equal to 246, B is equal to 1258, and C is 137. And they want us to find the following: A A and B prime. So let's go ahead and label this. Remember, this is intersect, which is and. Okay, so A and B prime, which means not B. So let's look at A. So A is 2, 4, 6. So I'm going to kind of do it this way just to kind of show you how my thought process works. I have 2, 4, 6. And not B would be everything else that's, let's see, that's not in B. So in B, let me rewrite that set here. We have 1, 2, 5, 8, but it's not, which means I can't use any of these numbers. Okay, that's one way to think about it. So what do they have in common? Well, they do have the 2 in common, because remember, or and means what they share. Okay, so they have a 2 in common, but I can't use it because I have that little knot that's pretty much taking it out for me. 4, they don't have a 4 in common. Okay, so we could use the 4. 6, they don't have that either, so I could use the 6. So essentially what I can do is I can use anything that's a part of the universal set. Remember that if it's not B, you can make a note here. So not B means I can use anything from the universal set. The universal set is this one, as long as it's not in B, okay? So I can use 4 and 6. So the answer for this one is just 4 and 6. You got to be real careful with these, especially when you have that not symbol. Excuse me. So for the next one, we're going to go ahead and deal with 3 of them now. Okay. I have A. Let me get a different color here. So I have A and B or C. Okay. So we're going to deal with it one at a time. So for A again, I'm using that 2, 4, 6. And I want to intersect that with B or C. So this part right here, okay, B or C means that it's everything in both of them, because or means it can be in either one. So for this set, I'm going to copy the entire thing. Let's say I have a 1. I don't have to put it twice. I'm just going to put it once. 1. I have a 2. I have a 3. I have a 5, 7, and 8. So again, I'm just writing every number down that's in B or C without repeating them. Okay. And now since we're looking at the and statement, so we kind of do it in pieces, I need to see what these two things have in common. So let's see. This has a 2, this has a 2. So I can have the 2. This has a 4, this one does not have a 4, so we can't use the 4. This one has a 6, and this one does not have a 6, so I can't use the 6. And at this point, I can pretty much stop because I can see that the rest of these, so the 1, 3, 5, 7, 8, they're not over here. So I don't even have to look at them because remember that the symbol for intersect means it has to be in both of them. So it has to be in both, okay? So my answer for this is just 2. These are gonna take some practice, guys, not gonna lie. Some of you might do better with the Venn diagrams, which I'm gonna show you in a bit, but just quickly just assessing what is in both, what's in one, what's in the other. That's kind of how you do it with the numbers, okay? If you have any further questions, and like I said, let me know. I'm happy to help with more examples. I think that's all I have for these. Yeah, okay, so we're gonna go ahead and look at the Venn diagrams now. We talked about them briefly in the section before, but they really come into play when we start doing these set operations, okay? So I have the exact same example from before, where we have u is equal to this, a246, etc. I'm going to use a Venn diagram this time to show you how you can use that to also solve a intersect b. Okay, so remember that intersect means and, so this means and it means whatever's in whatever's in A and B. So just quickly looking at it, let's see, A has a 2, this one has a 2, this, and then that's it. So they should only have a 2 in common. Okay, this should be the answer. But I'm going to show you how to do it with a Venn diagram. Okay, so a Venn diagram, you always start with a rectangular box. Okay, and what we do is we let U be pretty much the contents of this entire box. So everything that's in U, so all these numbers have to be in here somehow, okay? And then we're going to take A and draw a circle, okay? And we're going to take B and draw another circle because we're only talking about 2 letters, A and B. So B and A, okay? All right, so what I'm going to do is I'm going to put all those numbers that are up here into one of these 4 sections. We have 1, 2, 3, 4. It can land in one of those spaces, okay? So we're going to start with 1 because 1 is, I'm going to look at the universal set here. So universal set. So the 1 is, let's see, it's not in A, but it is in B. So 1 would land, oh, I'm sorry, I forgot to label B over here. This is B. Okay. So 1 is in B for sure. It's not an A, so I can't put it in any of these sections because anything that's inside this blue circle means that it's part of A also, okay? What about 2? Well, 2 is also in B, and it's in A, so that means it's going to be in the section here in the middle, 2, because both A and B have it, okay? Let's look at 3. A doesn't have a 3, and B doesn't have a 3, so 3 is somewhere out here in the universe somewhere, okay? It's in that C, but we didn't draw C for this one. 4, let's see, A has a 4 and B does not. So 4 would go here in the A circle, Notice that it's only in the A part because if I put it here in the middle, that means it's part of the green section too. We don't want that. Let me see, 5. Let's see, B has a 5 and A does not. So 5 is going to go over here in the green section, just green section. Okay. 6. Let's see, A has a 6. So 6 goes here. 7, neither A nor B have a 7, so it's somewhere out here in the universe, somewhere. And finally 8. 8 is inside B, so 8 would be right here. And that's it. So this is a visual of how you can answer this with a Venn diagram. You draw the circles and you see what do they share. So this part right here, I'm gonna kind of color it in. This part right here represents the union. I'm sorry, the intersection. The part that they share, they have in common. Okay. And visually you can see that it's the part where the circles overlap. All right, with that in mind, with a real brief intro to Venn diagrams, let's look at this monster here. Okay, so Venn diagrams, guys, can get really confusing if you don't read them carefully. So I'm going to briefly explain how it works with the picture here, and then we're going to try a few examples. This is going to be the bulk of the rest of the video. Just to kind of give you a heads up, the next section, 2.4, it shouldn't be too long. So hopefully this kind of balances it out, okay? So here we have a Venn diagram with two circles. Ignore the examples. Okay, we're looking at this right here, A and B. This is a Venn diagram with only two sets. I should put that. This is with two sets. Okay, A and B. A, B. They are color-coded and labeled. So if we look at region 1, okay, this is region 1. You have this 1 right here labeled. This is the part that they both share. So it tells you here region 1 may be an element of both A and B. So that's going to be this part right here, region 1. In other words, if I have a number, whatever the elements are, if it lands in this little space right here, that means that it belongs to A and it belongs to B. Okay, they both kind of share it. Region 2. Okay, so region 2 is going to be this space over here. Region 2 may be an element of A, but not B. In other words, if something lands in here, it's never ever going to go into the B circle. If it lands here somehow, then it's no longer just A, it belongs to both of them. So we don't want that. We only want it to belong to A, and that would be this part right here, set region 2. Okay. Region 3, so now we're looking at this part right here. Okay. So region 3 is kind of like the one we just saw, but now it belongs to B. So anything in this area that I'm shading right now is solely belonging to B. So it doesn't share anything in common with A. It's just by itself over here. Okay. And finally, region 4. So region 4 is this outside section that we kind of called the universe, also the universal set. That's why we have this U over here. Okay, universal set. May or may not be an element of either A or B. So if you have a number like the ones we had up here, the 3 and the 7, okay, they didn't belong to either A or B, so they end up out here in the wilderness, okay? Possibly belonging to a different set, but we just haven't discussed it or so, okay? But yeah, that's the idea, okay? So we're going to try to draw some Venn diagrams. These do take some practice, guys, not going to lie. They're not my favorite things. I honestly prefer just doing the set approach, but we got to have a little bit of everything, okay? Just maybe this is some person's preference. So we're going to start with example 1 right here. I should have put a 1 there. Example 1 for Venn diagrams. A intersect B prime. So let's go ahead and label this again because we have to remember what this means. This means and or intersect, and this means not B. Okay, so what I'm going to do first is I'm going to go ahead and draw my my box because we do have to have our universal space. Okay, remember that this box U is the entire space, okay? And I'm going to go ahead and do A on this side. So there's A, and this will be B. So if you have two letters, you want to start with two circles, okay? This one says I want everything that's in A and not B. So that would be everything in A, so that would be everything in here. I can't do this space because that includes B. And then it says not B, so this part is A. So for not B, that would be everything except B. So that means I could include the entire box. If that makes any sense. So if it's not B, it's the whole universe except for B. So it's everything except this space right here. And what we're looking for is the space where they intersect. So if you can kind of relate this to inequalities, maybe you guys remember the graphing of inequalities. It's looking for that space where both of the shaded areas cross over each other. And in this case, it looks like that happens right here. Okay, so that would be our answer for this one if we were being asked to draw something like this. Okay. If we look at another example, we're going to do the same thing. We're going to draw our universe first. Okay. You know what? I'll draw it, and then I'm going to give you a few maybe a few seconds to try to figure this one out. So there's A. It's a horrible circle, but there's A, and there's B. Okay. And take a few seconds. See if you can label what this means and shade accordingly. Let's see how well you can do with that. Okay, so we're going to go ahead and continue then. So first of all, again, this means and this means not. So you have to be really careful with this one because it's going to be what the way I would do this is I would find this piece right here and then do the opposite of that because this means not any of this. Okay, so A intersect B would be all of where A, so A would be all this. I'm going to do it lightly. Okay, and B would be all of this. So if we're looking for where they intersect, we're looking at the space in the middle because that's where they kind of cross together, right? But this is saying we want not that. So if I'm going to do everything besides this piece right here, I'm actually looking at everything else. I'm looking at the entire universe minus what these two things share. So I'm going to go ahead and erase that middle part. So this part is off limits. It's quarantined. Just kidding. So again, the space that I'm looking at for this one would be, oh, wrong one, would be, that's my A, would be all of this. Okay. And yeah, that's it, guys. That's pretty much it for the two. We're going to do one more because it gets a little bit more complicated when there are three of them. Okay. So this example has A and B or not C. So you might freak out a little bit because there are now three circles we have to deal with. So the first thing you want to do, and you have several examples in your book. I'm not going to go over all of them because it's a lot of writing. And you guys can read it if you need more assistance, or I can help you in a separate video if you need more help. But we're going to start with the universe. So here's our universe, our big box of universe. Okay? And we're going to go ahead and draw the circles. So I'm going to start with my A. So here's A, just like always. Here is B. And now we have a third circle. We have C. So I'm going to do that one in yellow. So C is going to go down here. Okay. And we're going to look at this piece by piece. So I'm first going to look at A, just A by itself, and look at this piece by itself and then this over here. So A would be this entire circle. Okay. It takes care of A. Then we're going to look at B or not C. So B would be this circle, but it says or not C. So that means I can do anything that is not C. So we have to be careful here because not C is going to be pretty much, it's going to take out this piece from us. So that means I have to get rid of this part right here. That part is no longer available. I got to take out my part that I did here with the B. So that part is no longer available. But I still have the universe. So I have to do the entire box, except for that C. So just to kind of recap, so you can see what's going on here. A is the circle, so that one's easy. It's just all this blue thing here. B is all of B, but it says or not C. So that means I would take out not C would be this part right here. You know what? Actually, we can leave it because it's B or, forgot. Or means it can be either one. So we have all this so far, okay? And we're trying to see where these things overlap. So where do you see the blue and the purple kind of all together in one? Well, I see them together. Let's see what color. I'll use green. I see them together here for sure. And I see them together here and here. Okay. Again, the reason I went ahead and put my lines back here is because it's or. And or means it can be in either one. So as long as it's in one of them, you can shade it in, okay? So it looks like this Venn diagram, if I'll draw it kind of here on the side just to kind of make it look a little bit nicer. But it looks like we covered only a small part of it once we got our answer. We did all of this parts. So all of A, and then these two pieces right here. And that is where they intersect in this operation, okay? And I think that's it. Yes, that is it. So I'm going to go ahead and let you work on your assignment now. If you have any questions, definitely let me know. This is a topic that can definitely get pretty confusing sometimes. So let me know. Reach out to me, and good luck with your assignment.